All right, in 1.3, we're also looking here at standard deviation. So it's another measurement of spread. So in this distribution, how far are the values from the mean on average? Well, the mean is probably in the center. If you balanced it, it would probably fall in the center. So if you look at these values, like this 3 right here is 1 below the mean. These two values are 2 below the mean, and this one value here is 3 below the mean. In the same regard, that 5 is 1 above, these are 2 above, these are 3, this one's 3 above. Now, if we average those, we'd end up with an average of 0 because they cancel each other out with positives and negatives. So we don't really average them, but we do create a standard deviation. And so what standard deviation measures is the typical distance from the mean. It's a distance. It can't be negative. It has to be positive because we measure distances in positive values. So let's look at some differences and similarities between range, IQR, and standard deviation. These are all different measures for spread. When you're doing SOX, the second S is for spread. You could use any of these values, but you need to make sure you use the accurate ones. So let's talk about what's the differences. Well, the similarities is that they all measure variability, or you could say they all measure spread, same thing. But there are differences. Not all of them are resistant to outliers. Okay, we talked about range is not resistant to outliers. We talked that IQR is resistant to outliers. And then standard deviation is not resistant, but we'll talk about that in a minute. Not all of them use all the data, okay? So like range doesn't use all the data, it uses just the maximum and minimum. IQR only uses the first quartile and the third quartile. It doesn't take into account the max and the min. So standard deviation does use all the data. Now, to rank standard deviation, IQR, and range from most resistant to least resistant, the most resistant measurement is IQR. Because, remember, it cuts off the low 25 and the high 25. So it takes into account just the middle 50% of the data. The next most resistant measure of spread is standard deviation. And you'll see the calculation accounts for some things in there in a minute. The least resistant is the range. Okay, range is what you learned in middle school, which is max minus min. That is really not an accurate measure of spread that we use in this class, so you won't be using range. Okay, if you've got nothing else but max and min, you can, but most of the time you have more information to use a more accurate measure of spread, like IQR or standard deviation. Okay, so here's your steps to calculate standard deviation. The first thing you have to do with your set of data is find the mean. The second is find the deviation from the mean for each data value. I'm going to walk you through it in a second. You'll square each deviation, and you'll add the squared deviations. You divide by n minus 1, where n is the number of values, and then you take the square root. So this is the step-by-step. So let's do this. Here's the formula. Here's where we're getting at. So I want you to be comfortable with this. The n stands for how many observations are on your dot plot or in your data set. Remember, the sigma means the sum of, and this I means each observation, subtracting the mean of the sample, and then you square it. All right, so we're going to break this down into pieces, okay? So here's each observation right off the dot plot. And we found that the mean was 4. So if I'm doing this portion of it right here. I'm taking each observation and subtracting 4. So I get -3, -2, on and on and on. There's my deviations. Now, like we said, you can't just add them like this because they cancel each other out with all the signs. So we square them. That's the squared part right here. We square them, they become positive, and we add them up. We get a total of 36. Then we divide by n minus 1. Well, there are 8 data points. Minus 1 means I'm going to divide by 7. And then I take the square root, and that gives me 2.3 values is my standard deviation. That's the typical distance from the mean. Okay? So it's a little tedious, and I'll show you some shortcuts, but you got to know the parts here. All right? Now, moving on. The average squared deviation, standard deviation, is called the variance. So this value right here before you take the square root is what we call the variance in statistics. Now it comes into play when we get into probability. We don't use it a whole lot outside of that, but right now you need to know there's the variance. And once I take the square root of my variance, that's what we refer to as the standard deviation. These are standard deviations that you need to know. Okay, first, it's only used to measure spread when the distribution is symmetric, where the mean is the center. And that's because it's not resistant to outliers. If it's symmetric, there's probably no outliers. So it's a better measure of spread when it is symmetric and not being pulled in one direction or the other. It's always greater than 0. So if S is 0, if my standard deviation is 0, that means all the data points are exactly the same, or it means there's no variability. It carries the same unit of measurement as the original observations. So as grams of fat in sandwiches or points per game. Now, standard deviation, notice the symbol, is not resistant to extreme measures. Outliers increase that standard deviation. And then lastly, standard deviation is the square root of the variance. And this is what we talked about at the end of the last slide, but you do need to know that. The standard deviation is the square root of the variance. So let's walk through an example. A random sample of 5 students was asked how many minutes they spent doing homework the previous night. Here's their responses in minutes. All right, there they are. Small data set makes it a little easier. Calculate and interpret the standard deviation. Okay, so the first thing I have to know, remember, is the formula here. Well, this is each observation. N is how many? I have 5 observations. Well, X bar is what I need to find out. What's the mean homework time? So I add up my homework times and then divide by 5, and I get a mean of 41. So if you remember the formula, the next thing I need to do is take each observation and subtract the mean. So I take each observation, subtract the mean. Then I'm going to square my deviations, total it up. Then I'm going to divide that total by 5 minus 1, or divide it by 4. That value right there is my variance. Then I take the square root and I get 34.7 minutes. Now, this is the calculate part. Now, the interpret part. It's important to teach the words. We would say the amount of time spent on homework typically varies by 34.7 minutes from the mean of 41 minutes. So this phrase, typically varies from the mean, is really key when you're interpreting standard deviation. That's what I'm looking for. Notice the sentence also has lots of context in it. You gotta have context, always have context. Now in your calculators, this will kind of walk you through how you can do this. If you put your data in the list and you go back out to stat and choose one variable stats, it will give you this output. And in the output, you're gonna find standard deviation, but you actually find 2 of them. Notice this one has SX and this one has sigma X. That symbol is a sigma, Greek letter sigma. Now, what you need to know is that the one we're going to use is the S, because that S stands for the sample standard deviation. And 99.9% of the time, that's all we have. The calculator for sigma here is assuming you know every population value. And we don't. Whatever we're measuring, we don't. So S of X and sigma X are both standard deviations that show up on your calculator output. S of X represents the sample standard deviation, while sigma X represents the population, which is rarely ever known. So as a result, make sure to always use the S of X value that appears for this sample standard deviation. All right, this is one last review of the measurements you need to use for center and spread depending on the shape of your distribution. Okay, if it is skewed distribution, like right skewed or left skewed, you want to use the resistant measures, which are the median and the IQR. Median for center, IQR for spread. Those 2 measurements are resistant to outliers, so you want to use them if my distribution is skewed in any way. If your distribution is symmetric or normal, you can use those non-resistant measures because they will correctly reflect the population values. Okay, in that case, you should use mean and standard deviation. It does matter which one you use. So when you're describing a distribution, it's important that you use the correct measure for center and spread. Don't just say the center is this or the spread is this. You need to be using words like median, IQR, or mean and standard deviation. Okay, center and spread were okay before we looked at these values and these measurements, but now that we've finished chapter 1, you are now required to use the correct values given the shape of the distribution. Okay, so make sure you're paying attention to that and you know which ones to use for skewed distributions and which ones to use for symmetric.